Last summer, my wife and I started working our way through a cookbook by the name of The Family Meal. It was subtitled Home Cooking with Ferran Adria. Ferran was the chef of El Bulli, which, while open, was widely considered to be the best restaurant in the world. A book like this sounds a little ambitious to try to attack, but its topic of focus was really intriguing to us. Ferran and the rest of his 75-person staff sat down before every service night and had a meal together. The meals were comfort foods from the staff's home countries, which actually spanned most of the continents. They were made from ingredients that were easy to store, purchase or substitute, and recreate. They consisted of 2 or 3 courses, all of which flowed together. And most importantly, they had to scale. The recipes in the book go from for 2 people or up to 75. So bringing everybody together in this manner, it was really important to Chef Adria. Making something that served his community and making something everybody could take part in creating or using by keeping the recipes simple and precise and by making the foods accessible is something actually that rings out to me beyond the kitchen. It's how we interact with one another. In our industry, it's how we best communicate. We build things that make others' lives simpler without unnecessary complications. We build things that think first about who is consuming them, not what technical expertise we can show off. Dr. Alan Kay, that guy, stated, "Let me argue that the actual dawn of user interface design first happened when computer designers finally noticed not just that end users had functioning minds, but that a better understanding of those minds or how those minds worked would completely shift the paradigm of interaction." So today I want to talk to you about building tools. Dr. Kay was talking more specifically about the GUI in that quote. But for many of us day-to-day code mashers, our UI is the command line. We use code and text to interact with our machines in the same way. If you switched context, you might use your mouse and windows and buttons. We install dependencies, we smash files together, we take human-readable instructions and make them into a language fit for a machine. We use the terminal as a means to an end to solve the problems that we're faced with. And well, there are a lot of amazing tools out there in order to do that. There's Gulp and Grunt, there's Make and Rake, there's NPM and Bundler and Pip and Homebrew and Git and Cat and grep and awk, and like a bunch of little words. And odds are you used at least a few of the tools. Each one carries with it the hopes of making your interaction with your machine smoother. But if you ask around, I'm 100% certain you'll find somebody who has a complaint about at least one of them. The opacity of APIs, the speed, the environment, the list goes on. And what it normally boils down to are human factors. These preferences for certain types of ergonomics in a field where the next hot thing is coming down the pipeline as we speak. There's one glaring problem that trumps all of those, though. Building tools is super hard. So, in the fall of 2012, Scott Gell popped into Filament Group's Campfire one Monday morning and demoed something that he'd come up with over the weekend. It was what we would first call Unicon, and then eventually we had to rename it. So we named it GruntAkan. GruntAkan is a pretty heavily used tool now. It allows you to handle your icon solution as part of your build process. It gives you feature-tested fallbacks along the way. It relied on Grunt at the time, and hence the name, and it really focused on the perspective of someone who didn't like spending much time in the CLI. And we put it out there, and people really ate it up. But then the obvious thing happened. Issues started piling up on GitHub of both the terrible bug and the feature request kind. Scott, he came in on a Monday. He'd written an exploratory tool over the weekend. This thing wasn't built for a ton of modification. It was built kind of early on in Grunt stages. Like it was on 0.3 at the time. So every time a bug or a feature came in that we wanted to address, we stuck that code just on there, like a rubber band on an ever-growing rubber band ball. Oh, that's loud. We had a choice at this point in the project. We could decide it was worth it. it had a lot of promise, and we could set aside time for it and really work on it. Or we could just throw on the README, hey, this is experimental. If you like the idea, fork it and make a PR for a README to put your version on there, and that we'll do that. And spoiler alert, we did the first thing because I wouldn't have anything to talk about if we did the second. So say you're in the situation we were in with GruntAkan right there. You or a coworker came with something over the weekend, and it was awesome, and you were super excited about the potential of the project. And right now, your script works. But you're starting to notice these little holes. There are no tests. It was tied to a build tool. It's super monolithic. So you've released it to the public, and well, like you put it up on NPM and GitHub and tweeted about it, and like whatever we call releasing things to the public. And some people found it interesting and started using it. And now your issues are starting to come in. So the first thing you're going to need, if you're ever going to want to build a project that you and your community can trust, is tests. We need to refactor this thing, and we need to make sure that it still continues to work while we do that. So my advice here is to write an integration test. You already have something that kind of works, so you've got an input and you've got an output. You know what to expect. So write a test that just matches that. And that's what works right now. So once you've got that, you can start rewriting this thing and know that you haven't broken anything that actually works right now. OK. When we write code, we write it for humans to read and interact with. It's an interaction, and like any good interaction, it works best if you are amazingly clear of what your expectations are of the person you're interacting with and what they should expect from you. That brings me to Pustle's law. Be conservative in what you do. Be liberal in what you accept from others. John Pustle was talking about TCP implementations at the time, but was onto something here on a broader scope. If we want to write something particularly robust, we need to consider what we're accepting as an argument, and if it's far too specific. If we can make what the user wants to work, we should. Humans will want to use the thing we built in use cases that we haven't thought of yet, and it's up to us to be immensely understanding and to help them when we can. On the other end, we need to be clear and consistent with our output. Keep the return type the same. Keep the format the same. Keep your output heavily documented. Make sure people know that they can process it. That being said, there's certainly some caveats to that rule. We're here at this conference, so a lot of people here write JavaScript, and that'll get you. Weak types are a thing. So let's make the rule this way. LEMBECK's law. Be conservative in what you do. Be liberal in what you accept from others. Unless what they're doing is totally absurd, then throw an appropriate and clear error for that biz. Because literally nothing is worse than failing silently. OK, maybe there's a few things that are worse than that, but mostly those are wasps. So since we're talking about command line-based tools here, what are some examples that you might want to think about? How many arguments are expected? The order of said arguments. What should your defaults be for options? Do you take input from standard in? What side effects might the user incur? Are you expecting a specific build tool or task runner to run your code? On that last one, personal experience from this project, don't ever do that. For the rest of these, luckily enough, there are documented and storied patterns and tools. And that's awesome, because you can pick one of these and follow its general rules, and you're a good part of the way there. It's nice. So let's talk about some of my favorite patterns, ones I commonly use, ones that I come across regularly. First up, the filter pattern. The filter pattern is when you take input from standard in, and then you transform the data, and then you output to standard out. It's commonly considered the Unix way. It's super common in Node via like the Stream API. The most common place I see this on my day-to-day are tools like grep. But I also see it quite a bit in the gulp file. So that's the filter pattern at work. It takes in data, it pipes in to a transformer, and it pipes it to where something's going to write to a file. In this case, it's taking our stylus files and transforming them to CSS, and then outputs them. Since I mentioned GruntAkan, let's think of a way we can bring the filter pattern into that project. The first module and part of GruntAkan, as it stands right now, is a module named Directory Colorify. Directory Colorify takes in an input directory, reads through the files that need to have their color changed, and then changes the color of the files, and then writes the files to a new directory. So at a more granular level, it loops through the directory, reads the contents of each file, processes the file content, and then writes to file in a new directory. So like this is kind of perfect for a filter pattern. On the command line, excuse the bash, this might look like this. So ls lists files in your directory, and as those are listed, they're piped through to a while loop, which reads through them. It'll output the current file's contents, and then it will perform the color transformation. And that then directs output to a new file. And I should really change that so it works that way soon. Next up is the Cantrip pattern. It runs a command. Like you run a command, you don't give it standard in, no output comes from standard out, but something happened along the way. You'll see this all the time, but it's super side effect driven. So it's best to communicate with your user through your man file or your docs that all they'll see is an exit status or an error to go along with the side effect to let them know it didn't happen. You'll see this quite a bit with RM, to remove a file, or touch, which just like creates a file that's empty, or clear, which just clears your screen. Using the directory colorify example, this is kind of easy to imagine. We could have directory colorify, take a couple parameters, that input directory, the output directory. I could probably throw an option on there for color. And unless there's an error, you're going to get no feedback. All the files were created, so I guess you're done. All right. The source pattern. No standard in, but you output to standard out. Source pattern is dependent on the system that you're working within and frequently reports the state of said system. An example of this is ls. It lists the files that are in your current directory. For the sake of consistency, here's how I would shoehorn this pattern to the directory colorify module. And to be honest, I probably wouldn't do this. And that's good because eliminating a potential pattern is useful. But let's look at the example anyway. So directory colorify would do the reading of a directory, and then it would perform all of the color transformations for you. And then it would output the files that have been transformed, probably with a new line separating them. So you can afterward, so that's just the top line, so you can afterward read line by line, put the outline, and then put each line into its own file, and write to file. And the last example I'll give is the compiler pattern. So the compiler pattern might seem pretty familiar to you in concept. It reads files, it performs transformations, and then it writes files. It doesn't do it from standard in or standard out like the filtered pattern, though. It actually reads and writes files itself. The namesake comes from compilers, but you'll see this enough in, say, grunt tasks. The directory colorify example of this is interesting enough. We read through our input directory. We rock that while loop again on that list of files. Colorify will handle the file reading, the transformation, and the file writing, which is kind of a separations of concern problem, but that's that. This is kind of how it works right now. So when it comes time to address how your tool is interacted with, you should give a thought to these kinds of patterns. When you use established patterns to create your software, it's likely to be a familiar feeling, and that makes your intentions more transparent, which gives user experience that prioritizes ease of use. So ease of use doesn't just cover using established patterns and adhering the best you can to Postel's law. Keeping the surface area of what you handle with your tool small and simple to grok means that your users have less cognitive overhead when adding your tool to their arsenal. The idea comes back to something else a bunch of smart folks said 30 years ago that still holds true today. Write programs that do one thing and do it well. Write programs that work together. So say you've got GruntAkan on your hands again. GruntAkan started as this monolithic tool that took a couple of arguments. The main arguments were an input directory, to read from and an output directory to write to. So once it had those things, it read the input directory. It performed color changes on all of the SVGs that were requested of it. It converted the SVGs to PNGs. It created a separate CSS file for the SVGs and the PNGs. And then it created a loader snippet for feature detection and loading. And then it created a preview HTML file so you could see what your results were. And it was written in like 2 or 3 functions. So maintenance on this was hard. So we rewrote it. Now, GruntAkan is composed of a few different small libraries. Honestly, the separation alone closed several issues, as folks kept asking for small pieces of the functionality anyway. It also made maintenance dreamy in comparison. Domain knowledge was able to shrink and be distributed. We used semantic versioning, and that made internal updates really easy for us. And tests, oh, they were way easier to write when we had like a bunch of little functions that do one thing. So, do one thing. Do it well. This makes your code far more reusable. It makes it more useful. It makes it small. It makes it simple. You can make it reusable. You can follow established patterns. Make it accepting of all sorts of potential input and incredibly explicit in its output. So you can make the user experience something you take pride in. Because honestly, when people talk about tools, that's what they end up talking about. And now that you've done all that, it's time to talk about the last part of building something like this. Look around you. These people that are here, they're your community. And when you start building tools that get a little bit of traction, you're going to need them. Because when you try to go at this alone, it will wear you down. So when dealing with the community, be quick as you can to answer tickets. You don't have to fix issues right away. I mean, sometimes you don't have to fix them at all, because people get when a feature is out of scope. But letting them know that they're heard, that's a pretty important place to start. Set up contribution guidelines and a code of conduct. You need a place to point when someone isn't meeting the expectations of your project. Because remember, this whole thing is about people. Like, when you're building this stuff, it's about people. And it's about interacting with people. It's about building things for people. So guidelines help set the bar for how we converse with one another. No bike shedding allowed. Make code style decisions early. Adhere to them. Make it linting and enforcement of those code styles part of your build. Because if these things come in a pull request, like, nobody should ever have to tilt at that windmill. Don't be afraid to hand over the keys to your project. Like, if somebody's making contributions to it, give them a commit bit. You'd be really surprised at how well humans handle trust. Use tools to build your tools. Starting everything from scratch is the path to tears and madness. So in the spirit of people and goodness that we're talking about here, I'm going to give a shout out to one of my favorite tools for building CLI stuff. So if you want to get started on it, that's a really good place. I used Yargs, and the people who make that clearly know what they're doing. So thumbs up. OK. If you are a person who's not building these, but is instead using these tools, remember to be kind. I'm 100% certain that I'm not the only person in this room that's received a nasty email or a GitHub comment or like getting a thirsty rando while up in my Twitter mentions. We're all people here, and we're professionals, so that behavior is unacceptable and will not be tolerated. What it comes down to at every part of the process is finding all of the empathy you can muster and utilizing it. Finding a way for your users to interact with the machine in a context that you've defined in order to solve a problem that you've run into, that's difficult for a multitude of reasons. But really understanding the user and their problem and how the tool can solve it, that's the most important reason. So let's bring it back to the beginning. You've come up with your little one-off script, and you're pretty proud of it because it's useful. And you're looking at sharing this thing, and like you can see potential in what you've built. That's fantastic. I'm super excited for you because that is a really, really good feeling. But now, be aware that you're a little bit blind because of the extent of your domain knowledge. Someone really smart once said, "We don't know who discovered water, but we're pretty sure it wasn't a fish." That thing that you put out in the world, if it has users, that's not just yours anymore. Once you get to a point when you're thinking the public can and should use your product, it's time for you to revisit and really think about the interface you put together. So, like, who is this for? What are they looking to do? How are you making their lives smoother? These thoughts should be running through your mind while you build your tool, and the answers should be ready to change as soon as you get more knowledge about who these people are. Because we build so much open source software. There are over 160,000 packages on NPM right now. So if you really want to differentiate your product from others that do something similar, you can start by empathizing with your users. We've got the tools and we've got the technical know-how. It's been a cornerstone for our entire industry for decades. So let's get out there and build some stuff. Useful, useless, fun, boring, none of that stuff matters. What matters is that you think about people while you make these things. Thanks.